Good morning, everyone. Welcome to this event. This is the EFSA webinar on the calculator for the estimation of non-dietary exposure to plant protection products, the so-called OPEX calculator. We have received lots of interest in this event with almost 600 registrations, so I hope it will be really useful. Next slide, please. My name is Arianna Chiusolo. I'm a scientific officer in the pesticide peer review unit of EFSA. I'm now introducing the event and some technical information on the webinar. Then my colleague Frederic Stas will present an overview on the OPEX calculator functionalities and some practical examples. After this, in a short question and answer session, my colleague Matilde Colas will present the questions received at the registrations with a prepared answer. And then at the end, I will close the event with some follow-up information. The participants can ask questions whenever during the webinar using the chat. Question will be addressed directly in the chat box by the contributors that are listed in this slide, namely Jose Cortinas from EFSA and the external experts Dagmar Bemelmans, Denise Bloch, Sabine Martin, Paul Hamey, and Peter Craig. Questions will be addressed as much as possible, of course, depending on the number of questions received and considering also the large attendance we have. To this point, I would recommend the participant to submit questions that are pertinent to the topic of the event, so the functionalities of the OPEX calculator. Please focus your question on this topic. Other questions, for instance, related to the amendments in the OPEC guidance and clarification, or its implementation and future updates, will be considered out of the scope. Next slide, please. And with this slide, I want to give you a short webinar guide. So first of all, the webinar is going to be recorded. The language is English, therefore also questions should be submitted in English. Please, as said, use the chat box on your right for submitting questions at any moment. Once addressed the questions by the contributors, both the questions that you have submitted and the answer will be visible to all in the chat box. You are, as you can see, automatically connected to the audio with the listening mode. So now I leave the floor to Frederic to present the functionalities of the OPEX calculator. And next slide, please.
Okay. Good morning to all of you. Welcome to this webinar. I'm Frederic Istas, a scientific officer in the pesticide unit in EFSA, and I will present you the functionalities of the calculator. So first, I will give some historical background. I will present you how to access the calculator, and then I will give some practical examples with the online tool. Next slide, please. Thank you. As historical background, you know, the first EFSA guidance on the non-dietary exposure assessment of operators, workers, residents, and bystanders was published in 2014. And it was including an Excel calculator with scenarios for outdoor uses, also some worker re-entry scenarios in greenhouses, and it included different risk mitigation measures, protective equipment, technical equipment, buffer zones. And these were the first EU-validated approaches for non-dietary exposure assessment. A few years after the publication of this guidance, EFSA received a mandate for an update. Next slide, please. And this first update has been published in 2022. As a new scenarios in the update, we have now greenhouse scenario, also for operators, resident and bystanders, so not only for workers. It includes also a revision of some crop and human parameters based on an updated status of knowledge. And it is offering a new online calculator with improved functionalities that I will show you afterwards, with a manual of formulas that are used in the calculations. And it has also an impact assessment in Annex E of the guidance as described. Next slide, please. So first, I will explain you how to access this new calculator. So you go first to the link on the EFSA website, as it is presented here. And then you can see you have two options. Either you read the article online or you access the PDF. If you choose to access the PDF, you will be able to download the document and read it on your own computer. Whereas if you choose the option read the article, next slide please, you will be able to access the online guidance where going to the different sections, you can have an overview of the sections when you click on this button. You will see that you have supporting information. And in this supporting information, next slide please, you will have the different annexes to the guidance. So you see Annex A, B, C, D, E, F, J. And in the Annex E, you will have all the explanations about the new calculator, including the links to the different documents that are available. So among the links that you can find in this Annex E, you have the link to the calculator itself, but you have also the link to the manual with the formulations and the link to the relevant R package used in the tool. So when you use the link to the calculator for the first time, for your first access, you will need to register. Then the following access, you will use the password that you have entered as after registration. Next slide, please. Then the other link that you can find in Annex E, as I told you, are for the manual and for the R package. You can see the two red bullets on the left side of the screen for the two documents. And on the right side of the screen, you can see the first page of the manual. I can show you a bit more how is the manual. So on the next slide, please. So you see here an extract of the table of content of the manual for the operator. You have the description, you have several divisions. So for solubles or granules formulation, for outdoor, indoor uses, and then for each of them, you have the different scenarios under consideration for which all the formulas are given. So I will show you in the next slide, please. How are these formulas? As example, you can see here some formulas for operators. And these formulas are giving estimates of external exposure. And then below, you will have for the details of the further calculations for correction for absorption, thermal inhalation, for correction for additional protection, personal protective equipment or respiratory protective equipment. And then you will have explanation on how everything is summed up and compared to the toxicological reference values. Next slide, please. And in the manual, you can see here the rest of the table of content. You have also the same explanations and formulas available for worker, resident, and bystander, divided the same way for solubles and granules, and then for outdoor or indoor uses. And so for worker, you see the different scenarios available, and for resident as well as bystander, you have the same 4 exposure pathways than in the previous calculator. So spray drift, vapor, surface deposit, and entry into treated crops, as well as recreational exposure as a separate scenario. Next slide, please. And also important, in this manual, you can find an appendix. And in this appendix, you have different tables with showing all combinations and default values that are used in the calculations. You have here an example of a table for worker. You can see that according to the crop type, you have different re-entry activities that are possible and combined. With the default duration of exposure, body parts that are exposed, and the different transfer coefficient with or without use of personal protective equipment. And as well for resident and bystanders, you have different tables with default values that are used in the calculation. Slide, please. And after this introduction to the links and supporting documents, we can start with the presentation of the calculator itself and its functionalities. So you can see here the icon that will appear when you will open the link to the calculator after your first registration. Next slide, please. And in this calculator, you will see a nice toolbar with different tabs. You see you have the info tab, data entry tab, summary, operator, worker, resident, and bystander. And let's look at the first tab first, the info tab. In this info sheet, you can find a description of all registers. You can find also the technical documentation, so information on the R package that is used in this version of the calculator, the legend of all the icons that are used in the calculator, also the meaning of all abbreviations that are used in the calculator, and background data. I will show you with more illustration during the practical examples what you can find in the info sheet. Next tab, please. Next slide, please. Something I think important and useful, because this was also a request, the explanation of all personal protective equipment is given in the info sheet. So even if it does not appear in the result of the calculator, you can find in the info sheet all this information, as well as the protection factors that are related to each of them in further tables. Next slide, please. So after this info sheet, where you also find all instructions on how to enter the data that I will explain now, you have the data entry tab. In this data entry tab, you have 4 sheets for data entry. You need to enter data for the product, for the active substance, for the application scenarios, and for the intended uses. So we'll start with the product on the next slide, please. Okay, so you can see for the product, you can also use a product that you have already saved earlier. So the first option, load saved product. Or you can enter a new product name. Then you need to choose the formulation type that is under consideration. So as you have already seen in the manual of formulation, you have solubles and non-solubles, which are granules. And on the next cell on the right side, you can choose if you use water-soluble bags, if the product is formulated into water-soluble bags or not. It's only here that you can choose this option, not later in the other entry sheet. And then you choose the product category, herbicide or other. Other can be fungicide, insecticide, etc. Next slide, please. Then when you have entered all the data for your product, so only one product can be entered at a time in the calculator, you have a summary of this data appearing on the right side. If you are happy with this data, you can go to the next entry sheet by clicking on the arrow on the upper right side of the window. Next slide, please. And you go to the second data entry sheet for the active substance. So of course, you start by writing the name of the active substance, and then you need to enter the concentration of the active substance. The concentration is expressed as technical material, meaning the material that has been used in the toxicity studies to derive the AOEL and the AAOEL. It's not the pure active substance, it's the technical material. Then AOEL, AOEL are the toxicological reference values. The next cell on the right is vapor pressure. The default value appearing is 0.001. If you delete this value, no results will be shown for exposure to vapor. You should know that the same trigger value applies than in the previous calculator. So we have two default values for air concentration, depending on the vapor pressure, which are 1 microgram per cubic meter and 15 microgram per cubic meter. And it depends if the vapor pressure is above or below 5 multiplied by 10 minus 3 pascals. But then I will explain at the end of this slide how this can be refined in the calculations. Then the second part of this data entry sheet for the active substance is for thermal absorption. So in this table, the concentration of the active substance that you have introduced above will automatically be reported in the first column on the first line. If you have or you do not have experimental data for the concentrate, you need to enter here manually the value of the thermal absorption. So if you have experimental data, this will be the value from the thermal absorption study. If you have no experimental data, it will be the default value, but you have to enter it yourself. And then in the second lines, you have the different dilutions tested in the thermal absorption study when it is available with respective thermal absorption values that you need to enter. So here you enter only results from experimental study or the default for the concentrate. You will see later in the intended use when you have no experimental study where you have to enter the thermal absorption values for the dilution. It will be in one of the next sheets. Then, in relationship with the vapor pressure that I mentioned earlier, we have here as a last possibility on this sheet, the air concentration calculation. This is optional. If you do not enter any low and might trigger a lower air concentration than the default value of 1 microgram per cubic meter, the lowest, you can enter the true value of the vapor pressure in the cell above, and then in this cell below, you enter the molecular weight of the active substance. And the calculator will calculate the saturated vapor concentration. And if the value is lower than the default value, it will be used in the next calculation. But if it's above the default value, it will not be used in the calculation. So don't be surprised if there is no change in exposure by inhalation, even though you have filled in these cells, because it depends on the results. Next slide, please. So when you have entered all the data for this for one active substance, you click on the Add button, and you can enter other data for a second active substance, for a third. I mean, several active substances in the same product can be assessed in the tool for combined exposure. And you see also on this line that on the right side of this screen, of this overview table, you can decide to delete one entry or to modify it. And then if you modify it, it will go back in the upper part of the screen. You will need to re-enter to change the data you want to modify and to push on the Add button again. And it will come back in the overview table with the changes you have made. Next slide, please. So after data entries for the product and active substance, we come to the data entry for the application scenario. So at first, you need to select the crop. So you have a predefined list of crops, of crop groups, and you need to choose. Once you have chosen your crop group of interest, you see that different examples of crop type and crop specific crops will appear below. So you will be able to check if the crop you are interested in is included in this group, in these examples. Next slide, please. Then always for the application scenarios, the next cell is you have to choose between indoor and outdoor use. Once you have chosen this, the next one is the re-entry activity. You see here, for this example, for outdoor uses, we have one cell for re-entry activity, and you need to choose a re-entry activity among the ones proposed in a predefined list. And once you have chosen this re-entry activity, you will see just below the crop examples that the dermal transfer coefficients for workers that are applicable to this re-entry activity will appear. Because these are default values, cannot be changed in the calculator, but you are informed here of which default values are used in the next calculations for this use. Then after the data related to the crop, you need to enter data for the application rate. Here, there is a big difference compared to the previous calculator. And this difference is that you have to enter the maximum application rate of the product and not of the active substance. Because the application rate as active substance will be calculated in the tool with previous data that you have already entered about the product. Here, it's the amount of product that has to be entered. And you can choose a number of application, interval between, if you choose more than one application, the cell with an interval between application will appear and you can adjust it. The default is 7, but you can adjust. Then you have the type of cultivation, the minimum volume of water. I think I gave, next slide, please. More example on this on the next slide. Yeah, maximum volume of water. So the minimum volume of water is used for the exposure estimates, while the maximum volume of water is used within the tool to calculate the thermal absorption if the experimental value that has been tested is not the same as the highest dilution from the use, then there will be a pro rata correction already done in the calculator, according to the EFSA guidance on thermal absorption of 2017. Then the last section of this data entry for the application scenario is the method of application. So you can usually downward, upward spraying is automatically selected according to your previous choice of crop or herbicide. For example, when you select at the beginning at the product level herbicide, it will always be downward application. While if you select other type of herbicide or other type of product and a high crop category like orchards, you will have upwards application available. And on the in the next cell, you have the application technique. And here you can see that there are 3 application techniques, but you can select only one of them if you are interested to see the results of only vehicle-mounted application, for example. The others can be deleted. Otherwise, the results are shown for all the 3 application techniques. And then, as in the previous calculator, you can choose the buffer strip to 3 meter, 5 meter, 10 meter, and the default drift reduction value also is the same as in the previous calculator. It's 50%. Next slide, please. Here, I wanted to show you an example of indoor use. So for the previous application scenario, I show you outdoor use. There was one re-entry activity for worker, While you see here, in the case of indoor use, you have also a second cell for reentry activity, TSF, and this one is related to exposure by inhalation, because for workers re-entering greenhouses, we have also, the calculator is also providing exposure estimates by inhalation. And these TSF factors were also included in the previous EFSA calculator, so for worker re-entry in greenhouse. And you see that for indoor use, the type of cultivation can be normal or dense, while in the case of outdoor use, it's always normal, but for greenhouse, it can also be dense. And all the rest of the cells are the same for indoor use. Next slide, please. So when you have added this application scenario, by clicking on the Add button, you can see below the overview of the different uses that you have entered in the tool, and they are numbered, use number 1, use number 2. And you can see here the difference. The first one, it was for outdoor use, the second one for indoor use on low vegetables. And you can see all the different combinations, so that here all application techniques were kept, so the results will be shown for all these application techniques. Then once you have finalized your application scenario, again, you go on the arrow on the upper right side of the screen to go to the next sheet of data entry. And this last sheet of data entry is for the intended use. In this long table of intended use, it is here that you can enter the thermal absorption value, the default thermal absorption value for the dilution when you have no experimental data. So you see that you have this tick box. In this case, it is activated. Experimental data, yes, because we had entered value in the entry sheet for the active substance. So these values are used and reported here. While if you had no experimental data, you would need to untick the box here and enter manually the value for the thermal absorption of the dilution. If you scroll on the right side of the screen of this table of intended use, next slide, please. You will see that for the worker, the resident, and the bystander, you can also modify manually DFR, DT50 values when you have experimental data. That will substitute the default values that are shown here. As you can see, in this new calculator, different DT50 values have been implemented. So one for the foliar, the same as in the previous calculator. One for the air, DT50 air, for the inhalation exposure, and one for the soil, for the exposure to soil-borne residue. And they are used in the calculation of the safe re-entry intervals for workers. Next slide, please. So when you have entered all these data and checked the intended use, you come back to the first page of the data entry, and a big advice now is save your product. It is better to save your product once you have entered all the data, and you will see it will appear as a zip file that you can